Good evening and welcome to Tinkering with Akai. It's been a while since I've done an update video on the VT-110 project, and I still would like to postpone it a bit, but I think I got another part ready for now. When we last set aside the project, I had rebuilt the head drum and the capstans. Now let's continue with some assembly. Now let's start putting the thing back together again. Base plate, clean. Adding the spacers and standoffs again. Roughly fitting the partial wire loom again. And putting the main input connectors to the base plate again. And the main capstan. Followed by the secondary capstan. And a new belt. Seems to fit. Whee! Something is turning. Progress! I already mentioned before that I couldn't find a perfect matched service manual for my unit, but I think the one I got here is close enough to fake some knowledge. Make it work again. So, the power supply PCB contains the following circuits. A 9V voltage regulator from the 12V input, which is either the DC power supply or the battery. All circuits run on the 9V here, except the main drive motor and the solenoid. These are pulling directly from the unregulated 12V rail. Next, the final stage for the DC drum motor is on here. This is a brushed DC motor, as opposed to the main drive motor, which is a 3-phase synchronous motor. And lastly, there is also the trimmer for the battery indicator meter. The piano keys for the tape drive controls are dirty. A bit of IPA and some scrubbing helps a ton. The 5 buttons are almost identical. Besides the red one for record, the play button has mounting holes for an additional lever. The other 3 are indeed identical. Getting the base for the keys ready, removing the old grease and dirt first. This plate goes in first. It will be spring-loaded and is the element that keeps the keys pressed until another one is actuated. The switch on the wire loom needs to go in next. No way of accessing the screws at a later time. Checking the continuity of these before putting them in. I had some bad surprises with microswitches before. For reference, these microswitches mostly distribute power to the various components. There are different power rails for playback, record, and also for not playback and not record. Tiny screws, tiny nuts, and almost no wiggle room. A true joy. Trust me, give it a try. Now for the aforementioned spring loading. It is combined with a standoff, also a bit wiggly. I put in the button axle for reference before torquing down on the spring. Next we have the sliding plates. This is what locks out the other buttons during operations. And they are spring-loaded, of course. And here comes a little toggle lever. It is used for the forward rewind buttons to avoid going both ways at the same time. And another lever. This one, also spring-loaded, is what arms the end of tape mechanism. It moves to the resting position only when no button is pressed. And yet another lever. This one picks up on the forward and reverse direction and moves other stuff. And finally, the first button. I need to make sure that the spring is in the correct orientation. These are quite stiff and can easily land in someone's eye if not careful. It took a few tries to find the best way of keeping them in check. Which leads me to the better way. Hook it to the axle first and then tension it to the button. Rinse and repeat. Do not forget the mounting tab in between. And an extra lever for the play button. Done. Adding the piano keys and the wiring loom again. There is quite a bit of detective work involved here. Which wire goes to where? Mounting the repaired switch. It is indeed the playback or record mode switch. Some wiring is quite obvious, like the loom wrapping around that peg. Other elements, not so much. It took a bit of time and comparing pictures. Finally, actually torquing down on the piano keys. A part of the loom is sneaking past those, so I had to keep them loose until now. Next, the video head mounting ring. And the front panel controls, headphone output, battery indicator, and the main power switch. The little PCB on the bottom is next. It serves two purposes. One, it is a delay circuit for the play solenoid. That is, it makes the high power coil cut out after a second or two and only keeps the low power holding coil energized. That saves on battery and will also keep the solenoid cooler. The second function was very odd and not documented in the schematics. You can see here, the one switch that locks with the play button is actually an audio dub feature. You can record audio while the video plays back. Thus, the erase signal needs to be generated, but only for the audio head. To keep the oscillator happy, the video erase head will be replaced with an inductor of similar characteristics. And that one was moved to the little PCB on my unit. Let's continue with some mechanics. This little plate is the brake actuator. And this one is the forward and reverse activator. The release the brake connection for forward and reverse. And I have to remove the direction toggle again. The connecting lever wouldn't fit in otherwise. This is what finally will connect the rotating parts. To remake the rubber wheels, I first drilled out a bit of rubber to the nominal diameter of the wheels. Then I cut slices for each wheel and glued them together. Next, I made a little mounting pin and used it to hold the wheels. It was rather easy now to turn them to size. The first revived rubber wheel connects to the main capstan and drives a belt whenever forward or reverse is engaged. It is also spring-loaded. I need to make sure that it's not dragging when in the off position. The main drive motor goes in next. Again, the order of operations is based on access to screws, not functional flow. Testing the main drive belt. Well, it works, but it seems a bit loose. I'll order a tighter one. Next, the crazy end-of-tape detection mechanism. And the pinch roller mounts. Remember, we have two of these. Both are spring-loaded. Now seems to be a good time to take care of the tape spools. They have integrated slip clutches so they won't tear the tape. and mounting them to the base plate. And remounting them, this time including the little protective cover on the rear. Up next, the braking assembly. This little spring-loaded felt is what keeps tension on the tape during play and prevents the feeding roll from unrolling. Now to the actual brakes. The rubber pads are okay, and the angle of attack makes sure they grip in one direction and leave a bit of play in the other. The two rubber wheels for forward and reverse go in next. They don't quite reach. Too small? Or did I pick the wrong ones? Let's continue with the next lever. This one releases the brake in play mode. Look, a mechanical OR gate. Indeed, one of these wheels was the wrong one. With the correct wheel in place, the mechanism works much better. I tried a thick square belt first, and while it did seem to work, it had issues. More on that later. Reconnecting those two sliding switches also took quite some time. And finally, the play solenoid. This is what actuates the pinch rollers and releases the brake. Just doing a quick sanity check before bolting down the brackets. The linkage also has the take-up wheel drive on it. That's one of the other rubber wheels that I replaced. I had to move the motor cover over a bit so it wouldn't touch on the brackets. And there's also a clamp that adjusts how far that rubber wheel will be removed from the take-up spool. Again, I tried a thicker belt for the drive first. And the second pinch roller. The end of tape sensor is quite brute force. The microswitch is in the main power line, which means as soon as the tape runs out, all power is killed, not just the tape movement. And second, it is a mechanical feeler. When you hit any of the piano keys, it is released and pushes slightly against the tape. When there is too little resistance, the lever will turn off the microswitch. And I forgot a peg. It's for the tape counter, but that will be mounted last. Starting to rewire things. First off, the fuse. And the connection socket. 8 pins in such a tight space are a challenge. Sorry, I just couldn't point the camera at anything interesting during that. The battery compartment is next. Finally, that thing will stand on its own and not always tilt over. I did find affordable batteries that are close. The terminals might need a bit of bending and I might need a few millimeters of padding, but they should do the job. Adding the first PCBs. Here's the motor control and power regulation one. The spool wheels get their clamping rings back, and a random washer with a new E-clip makes sure that they both work fine. I never found those two parts. Let's have a moment of silence. The next PCB is called the Servo control. It makes sure that the tape and head speeds are up to the synchronization pulses. The last PCB on the bottom side is the sync generator. It creates the sync signals for the camera, so we have proper video to record. This one is certainly tight and shows signs of abuse. Notice the curvature? Fine-tuning the wire routing with the benefit of hindsight. And attaching the sliding switches again. The one with the linkage is the audio dub one, the other one is called still. And it turns out that it will enable the playback circuit when the machine is stopped, and thus show a still frame on the output instead of just idling. In the other position, the playback is disabled and the input signal is presented to the output. Now that the motor and voltage regulator are connected again, it's time for a bit of testing. The motors are always running whenever the unit is turned on, except when the end of tape sensor triggers, so I'm taping that on for now. Looks good. Reverse. Forward. Play. Record. Record will only trigger when the camera is connected. Selecting direct input also makes it go. And end of tape. Yep. Now adding the heads, starting with the drum. Even more wiring. The video head wires need to snake underneath the mechanical linkage. And of course all the linear heads. The erase one with the green wiring. and the one sub-track erase head for scrubbing the audio track, and finally the control and audio head. Now to the top two PCBs. These are the video processing one. This is what makes the video input go onto the tape and what's on the tape to become a video signal again. And finally, the audio and erase signal generator one. Connecting up the video head drum, the sensor coil, and I think this is a good point to break for the hopefully final part in the series. If you follow my posts, you already know that I found a broken video amplifier. I'm close to finishing this thing. Trust me, I had it playing an old tape and I have a valid input video signal through the video processing pipeline. I want to hold back to try the record feature until I get a clean copy of that old tape on my drive. Just in case somebody wants their private videos back. I will not publish these. Anyway, I hope you enjoyed this episode and are not too mad for making it yet another part. See you next time! Next we have the sliding plates. This is what looks out. No, it looks like I did something wrong here. Darn it.